Yes, welcome to this video. This video is about image deblurring and what are the various techniques that we can use in Matlab to perform image deblurring. Okay, so let me first go through this code in which we are using basically two techniques. One is using wiener deconvolution, and the other one is called the blind deconvolution. And then we'll use the Fourier transform technique, where we take the Fourier transform of the image and Fourier transform of the noise, and then we basically divide the two to get back the original image. Okay, so first let me go through this one. Here we take an input, the input image using imread command. Then we use imdouble. Then we create the PSF, which is basically the filter uh, that is that can be basically convolved with your image to create the blurred image. Then we display the blurred image. Then we use the wiener deconvolution technique. The command for this is deconv WNR. It's a built-in Matlab function. Takes as input the image, PSF, and the variance. And then we can perform blind deconvolution. For this, the command is deconv blind. And again, we are using f special. F special basically what it does is it creates a filter, a disk filter. We are using in this case. You can write down help f special to read further about it. Let me run through this code. Change folder. Okay, so it creates 4 images. First, this is the original cameraman.tiff image. Then this is the blurred image that we created. Image number 3 is the image that we got after performing after we used wiener deconvolution. So if you compare these two, you can see that it has been deblurred to some extent. And then this is the case of blind deconvolution. So you can compare these two images with this one, and you can see that deblurring has worked to some extent. Okay, so this was the case of using the built-in Matlab functions. Now we'll see how we can use the Fourier transform technique. Okay, so in this, what we do is we take as input the image again, we create the PSF, blur the image. Then what we do is we basically add noise to these images. So we add different noises in these three cases. In first, we add white noise, Gaussian white noise of variance 10 to the power minus 3. In this, it's 10 to the power minus 11, and this is the case of 10 to the power minus 8. So this can basically tell us what will be the effect of noise on deblurring. Okay, then what we do is we display the blurred images after we added the noise. Then we take the Fourier transform of the images. Then what we do is we need to pad the PSF basically to match the size of the blurred image. So here we are doing that part. H is capital H, and then we take the Fourier transform of new H. This capital H is basically the Fourier transform of the noise, and then we divide this by our the Fourier transform of the image, of the blurred image, and then we take the inverse Fourier transform. So y1 deblurred, y2 deblurred, and so on. So y1 deblurred will give us the deblurred image in case of zero noise. Y2 deblurred will give us the deblurred image in case of noise with variance 10 to the power minus 13, 10 to the power minus 11 in this one, and 10 to the power minus 8 in this one. And then we simply plot them. Let me run this code. Change folder. Okay, we'll wait for it to run. Okay, so this was our actual image, and this is the blurred image that we created. Now this is what we are concerned with. So this is the deblurred image. This is the case when the noise is 0. So this is the blurred image. I'm sorry, this is the blurred image in case of 0 noise, and what we got after deblurring is this one. You can see this is like relatively close to what the original image looks like. So in case of 0 noise, we've managed to like completely extract our original image. Then we added Gaussian white noise of variance 10 to the power minus 13 in this case. So when we deblur that image, we can still see some noise in this one. That basically tells us that the white Gaussian noise that was added is actually present in this one also. Now in case of 10 to the power minus 11, when variance is 10 to the power minus 11, which basically means that noise is more than this case, so the deblurred image in this case is quite bad. If you can see, you can't actually read what's written. And in case when we take variance equal to 10 to the power minus 8, we actually get nothing, it's all scribbled. So you can do one more thing, you can take even greater noise. Let me make this 10 to the power minus, let's say, minus 6 in this case. So this should be 10 to the power minus 6, and here also it should be minus 6. So in this case, what do we expect? We expect nothing, like we can see nothing, it will be completely destroyed. So as you can see, the deblurred image, we do not get anything. This is basically because the noise is too large to actually get back our original image. So yep, this was image deblurring using three cases. One where we used wiener deconvolution, other where we used blind deconvolution, and this one where we used the Fourier transform method. If you got any queries, you can ask me in the comment section. I'll be putting the code in the description. If you liked the video, hit the like button, and thanks for watching.